Hi, good morning, and welcome to the ZP FoodSense webinar. So we do this webinar every Wednesday at approximately 8 a.m. London time. Though I must admit today we've gone early because we do have some conferences that we're actually running and chairing. But let me jump straight into it. So this webinar is really intended to be a Q and A, answering questions that come in on the Food Sense for this week. And we had some good questions that actually came in just today, and we'll make it into next week's webinar. I just want to remind people that at ZP we have a bit of a, we definitely have a commitment to Food Sense, and that commitment involves weekly webinars, for example, and we do a monthly demo. So on the 26th of September, please make a note of it. There will be a live demonstration of Food Sense, and we always do kind of two live demos during that webinar. If you've got questions for ZP, please don't hesitate to reach out to us. So our website is www.foodsensetechnology.com, and there's a contact us page. So if you have any questions like the one that we will be responding today, please don't hesitate to contact us. So now I will go forward and say, today, I like this question because I feel like the science, has been really well done, and I'm really just going to help give it my interpretation of the science or the testing. So somebody's got a Food Sense, they've done a lot of tests, 15 samples, and they've got an offset between the HPLC and the Food Sense reading. So obviously when you're measuring the hotness of chilies, you've got HPLC, high pressure liquid chromatography. This is a $50,000 sort of dollar instrument. You've got panel testing, which really nobody's doing. You've got sort of guessing, which is the quality managers maybe testing the product, and then you've got the Food Sense itself. So it's the HPLC and the Food Sense that are objective, are trying to be objective. Now, we own an HPLC at ZP, so when we were developing this, we did a validation of our HPLC results versus our Food Sense technology, and we have this kind of correlation, and that helps us know that we are correlating with the HPLC. Now, that's also been independently done by academia as well. So there's a good guy called Charlie Rower at the University of Minnesota, and he has measured the capsaicin. He's actually measured chilies both by HPLC and by Food Sense. Charlie's conclusion is that actually he really likes the Food Sense, and his, I spoke to him directly. I didn't know about that he was going to do this study. He was, he basically bought the instrument and did it himself and then published. So I would describe it as independent. He liked the fact that he could do multiple measurements on the Food Sense, but he could only ever afford to do one test with HPLC. It's basically the problem that we were trying to solve, that HPLC is expensive to own, and if you don't own it and you send it out for outside analysis, you get different results. And what you'll find with HPLC is, so today I am going to discuss somebody's got an offset between the HPLC results and the results with Food Sense, but I am going to discuss that if you send that same sample to one lab, you will get one result. If you send that if you send that sample to a second lab, you will get a different result. If you send the same sample to a third lab, you will get a different result. So that means that, and I've seen this happen. There's, for definites, I've got, we've got evidence of this, that 3 different labs will give you 3 different results for the same sample. So it's really important to realize that HPLC, between the labs, does not give you the same result. So we would describe that as, they're not necessarily accurate compared to one another. If you send the same sample to the same lab 1 month with a sort of description, you'll get a result. If you change the description and send the same sample to the same lab a second month, you'll get a different result. And if you send the same sample to the same lab on a third month and again change the name of it, you will get 3 results. So between HPLC labs, if you send the same sample, you will get different results. If you send the same sample spaced over time to the same lab, you will get different results. So HPLC doesn't necessarily give you what you would consider kind of accurate or repeatable results. Now, the AOAC method for HPLC, when you read it, you can kind of understand that, you know, this is quite a convoluted method. So it's actually, you know, you get this certificate of analysis, but you've got to be careful with certificates of analysis from HPLC labs because they never put the error on it. Any measurement is actually associated with an error. So you don't ever really know what their error is. And these labs are not audited for the accuracy of their HPLC results. They may be audited overall for their, let's say, their accuracy, but they're not audited for the accuracy of their HPLC results. All that said, it's probably worth, you know, knowing that the AOAC method, when you actually read it and follow it, it's really quite complicated, and anything that's complicated doesn't necessarily then mean that it translates well to, you know, accuracy. It can be accurate, but it doesn't always, you know, complexity isn't always easy to implement. Now I'm going to get to the question in hand. So what's going on here is this. In fact, I've got the data. So I say here food sensors versus HPLC. I don't think actually the word versus is not a great choice of word, but there we go. So we got 15 samples, and they've tested these samples on the FoodSense, and they've got, you know, a result per sample. So on average, they have a Scoville heat unit for these 15 samples of 4,109. They test the same samples by HPLC, and they get, you know, for example, sample 1 on the FoodSense is 3,818. On the HPLC, it's 6,358. So that means that they have a difference of 2,540 between the two. First of all, you know, that sounds like a massive difference. I just want to let you know that anecdotally, and you can check this up independently of me, you can do your own research online, you'll soon find the same answer. Tabasco sauce, you know, that famous brand in the US, they ship with a Scoville heat unit of 2,500 to 5,000. Why that is important is you must understand that Tabasco sauce is a, you know, is a sort of a very large, the company in a very large product. The company that owns it, you know, it's not insignificant. They have quality system in place, but what they're saying is, if we ship a product between 2,500 and 5,000, the consumer cannot recognize the difference of 2,500. So I just want you to know that when you do organoleptic testing or tasting, if the subtlety in the difference is 2,500, the consumer cannot necessarily detect it. And if you want me to prove that, think about Tabasco sauce. They ship it in the range of 2,500 to 5,000, and we do a lot of testing on this product. So we know that that is actually the case. So therefore, differences of, let's say, 2,500 are not discernible by the human tongue. Anyway, that said, so sample 1, 3,818 on the FoodSense, sample 1 on the HPLC, 6,358, and the difference in that case was 2,540. When we look at all the samples, we found out that we get an average difference of 2,236. Now, I would say that the gold standard for testing the hotness of chili products is actually the FoodSense. So we are the accurate one, and the HPLC is offset from us. So we're very, very well correlated with the FoodSense, with the HPLC in this case, but we're offset by 2,236 Scoville heat units. Now, if the user may think, actually, no, my HPLC is accurate, and it's the FoodSense that's offset. Now, FoodSense is really intended for people, and this is one of those kind of people who are producing chili products. So what's really important for people when producing chili products is the repeatability of their products and their processes, so that they produce a repeatable, like I say, product. So it's important actually that they get repeatability in test. So I would argue very strongly that this person actually has very repeatable test. What they have is an offset between the FoodSense and the HPLC. Now, whether FoodSense or the HPLC is the reason, let's say, for the offset. Now, I have laid out that actually if you sent these samples to a different HPLC lab, you'd get different HPLC results. So I would argue that actually it's FoodSense that's accurate and it's the HPLC that's offset. But if you've been producing a product for quite a long time and you've been testing it by HPLC, you want to show consistency with time. So therefore, how I'm going to deal with this inquiry is actually to show how you can measure on the FoodSense but report the HPLC result. And so it's simple enough, and I'll just sort of back up slightly and say if what you'll notice is the average offset, and I've just make sure that that's actually let me just make sure of something. Yeah, let me just shrink this down a bit. I realize, yeah, and that wasn't so clear, so I'm just dragging that out a bit so that you can see it. The average offset between measuring on the FoodSense and measuring on the HPLC was 2,236 Scoville heat units. And this is quite remarkable actually, because what you'll find out is that if I take, whoops, the data, I just want to go back one. This means that HPLC is expensive to run. It's expensive to own. People don't do a lot of HPLC testing because it adds too much cost. But if I wanted to predict the HPLC result because I had historical data that I wanted to be in line with, then predicted HPLC result equals FoodSense result plus 2,236. So what I've done on the next one is said sample 1 had a measured HPLC result of 6,358. If I adjust the FoodSense result by adding 2,236 to it, I get 6,053. If I do the same, I think the point, if I do the same on 6,324 and I add the offset, then I get 6,594. I'm just looking at my calculations, wondering why I'm getting this 0.8. But if I take the third sample and which had an HPLC of 6,271 and add 2,236, I get 6,060. So you can see that I offsetted it every time. I believe FoodSense is accurate, but if you want to correlate 1-to-1 with HPLC, then you add this offset of 2,236. I think the offset is a problem from the HPLC, but that's my opinion. What that means then is you have an error, for example, on sample 1 of 5%. You have an error on sample 2 of 4%. You have an error on sample 3 of 3%. So it's just using simple arithmetic. So predicted HPLC result equals what the FoodSense said plus 2,236. If I just do that adjustment, I get a series of errors, the worst of which is like 7%, which is really nothing when you consider what I would describe as a very heterogeneous sample. This is natural materials; they're not homogeneous; they're heterogeneous. If I average all those errors, do you know what the error is? It's 0%. So this tells me that the FoodSense and the HPLC are extremely well correlated with one another, and it tells me that actually a simple adjustment to the FoodSense result will give you a 1-to-1 correlation with the HPLC. I personally don't believe the HPLC is the accurate one, but we understand at ZP that you need to show consistency with historical data, and that's a simple way of essentially getting to it. One thing I would mention is what you'll notice about FoodSense is you don't do any calibration. And the reason being is at ZP, when we manufacture those sensors, we test them and make sure that the batches, the sensors are actually within specification before we ship them. So you can see overall a simple arithmetic adjustment to the FoodSense results leads to a very small error or difference between the HPLC and the FoodSense on an average, actually, over the 15 samples. That's why this is good science, because they did so much testing, is 0%. So well done. So you have your HPLC results, pretty expensive to actually obtain. You have your FoodSense results. Obviously, you've used it. You can see how quick and easy it is to use. You do have an offset between the two. I would also argue that if you really wanted to know the truth send the samples out to other HPLC labs and you'll find out the results there. It's an easy adjustment if you want to really correlate with your historical or with the HPLC results at 2,236. I'd actually suggest that it's the FoodSense that's telling you the truth. And just out of interest, differences of, let's say, less than 2,500 Scoville heat units are not discernible by the human tongue. And I would use the Tabasco sauce as the example there. And there I would say thank you. So you can see that as part of our commitment to FoodSense, when these kind of quite technical questions come in, we put some of our best brains on it, and we have a good think about it. We're pretty good at statistics and general sort of analytical chemistry. So if you've got any questions at ZP, don't hesitate to reach out to us. Okay, thanks very much.